lab. We're going to start it today and we'll get as far as we can today. And then if we need to finish it up tomorrow, we can. So we're going to do a lab about standing waves. When we were out in the hallway last week, it must have been last week, we had that big long slinky. Do you remember? We're doing all different kinds of stuff. One of the things that I showed you was standing waves. Do you remember what that looked like? Do you have a recollection?
Still.
It looked like it was standing still, right? Yeah, so the wave, it was moving, but it wasn't moving. Can you put your computer away, sweetheart, so I have your attention up here? Thank you so very much. So it was standing still. So you might want to draw a picture of this on your paper so you remember and you know it was standing still. So it was like there were spots that were not moving. Do you remember what those spots that were not moving were called? Started with an N also. Anybody recall that? Well, I heard somebody say it. The node, yeah. So the node, these are supposed to be even and nice. Mine is not very nice today, but you get the idea. The node is the place of no movement. So a node is a place on a standing wave where it is as if the medium is sitting still. It's not going anywhere. Okay? And then there are places where the slinky or the wire or the string or the whatever is moving really, really fast, but it's almost as if it's not moving. It's just not moving up here and down here, right? Knowing what we know about the English language, if this is a node, any idea, any recollection as to what these two things were called? It starts with an A. It lives in here somewhere too. Antinode. Wow, that was an interesting noise. But yes, it is an antinode. So an antinode is a place of maximum movement. You've got a lot of interaction going on, and then the node is the place where you've got what they call destructive interference. Okay? And today we're going to study them. We're going to study these standing waves. So you and your partner, you're actually going to be in groups of 3, are going to measure 3 meters between you. You're going to stretch a slinky out on the floor between you and your partner, just a normal plain old slinky. I'm going to ask that you be careful with my slinkies. Don't twist them and jerk them and break them, okay? Be gentle with them. Be nice. You're going to stretch your slinky out on the floor between you and your partner or one of your partners. One partner is going to move the slinky side to side to create a transverse wave. Remember what that is? That's not the one that goes, but it goes, right? So transverse wave with 2 antinodes. So this first time when you make your standing wave, it's going to have 2 antinodes. So it's going to look a lot like this one that we just drew. Okay? There's going to be a node at your elbow and a node at the other elbow and then a node in the middle and 2 antinodes in between those. Your hand should never leave the floor. The reason I say this is because sometimes people want to make transverse waves going this way. No, it doesn't work because there's a floor in the way. Right? So you've got to do it this way so that you're able to make that full wave. You're going to take a stopwatch or have that third person because we have 3 people, right? So one person on each end of the slinky, one person with a stopwatch. Time how long it takes for the wave to move back and forth 10 times. So that person that's moving their hand, 1, 2, 3, 4, 5, 6, up to 10. Get the idea? Okay? You're going to do that for a total of 3 trials. Okay? You see how this is going? Find the average time for 1 cycle. So you're going to find the average divided by 10, right? And then you're going to take data for not only that one with 2 antinodes, but you're going to do another one with 3 antinodes, another one with 4 antinodes, and another one with, I'd cross that 5 out and change it to a 1. Okay? 5 antinodes is pretty insane. It's really hard to get. I'm not saying that you can't do it. I'm just saying I don't want you to stress out about having to do it. Does that make sense? So you're going to do 2, then 3, then 4, then 1. Okay? Then you're going to graph the results. If you flip the paper over, I made this last year, and I made this funny data table because I didn't want to give you too much structure, but then it was dumb. I probably should have just left it blank. But it is what it is, so there you go. So you got some lines. Do what you want with them. Or if that really causes you a lot of stress, then just get a piece of paper and make your own data table. I don't care that much. Okay? Once you've got your data, hey, there's a graph right there for you. It's just waiting. It's right there waiting for you. There it is. Okay? Then you're going to do some graphing. And then after you do the graphing, you're going to answer the analysis questions. It's a little funny since the analysis questions are on the front. It was just so I could fit it all on one piece of paper as opposed to having to do multiple papers because that seemed like a waste of paper. Okay? Is this making sense? We okay? We understand what we need to do? Okay. You've got the rest of the period today. Last period, we needed a little bit more time, so I was going to go 5 or 10 minutes to finish up tomorrow. Okay? But get as far as you can today, and then we'll go from there. Sound good? There are slinkies over there. There are stopwatches over there. You know where the meter sticks are? Groups of 3, please.
All right. Because they already. Okay, so